So this is the progress on my home low humidity swamp cooler, which is basically I wanted to make a swamp cooler, but I didn't want all the humidity because I have a lot of electronics in the house and humidity is already really high. So I found this radiator on Amazon. It was 25 bucks. It's for a Mazda 6. It's just aluminum standard car radiator. I didn't want to use radiator hose, so I actually 3D printed these parts. They're actually connected by a cylinder, a hollowed out cylinder that's 30 millimeters in outer diameter and 25 inner diameter, and that is super glued on the inside of these radiator hose fittings, which are designed to have something shoved on the outside and then ratcheted down. But I didn't want to try to measure this with a 3D printer and try to print that accurately. So I noticed the inner diameter was exactly 30 millimeters. And so I went on ahead and just printed that. In the future, if I did this again, I would make the outer diameter slightly larger, like maybe 30.1 or even 30.5 millimeters. So I get some friction pressure. Because it did just kind of slide in really easily, and I was worried that super glue wouldn't be enough to seal it. But turns out I was wrong, and all it took was some super glue on the inside, and then I dribbled some around the outside to seal the outside edge, and that was fine. So that adapted the 30 millimeter inner diameter to 5/8 inch barb, and then I bought some 5/8 inch barb Tygon, hooked it up. Up here is a part that I initially 3D printed, but I got the barb size wrong, so I just went, or the threading size wrong, and just went to the hardware store and got a 1/2 inch pipe to 1/2 inch barb, which if they had 1/2 inch to, or 1/2 inch pipe to 3/4 or 5/8 inch barb, that would have been better, but they don't have that. So this is 1/2 inch inner diameter tube that then is spliced to 5/8, and then that goes into the radiator, that goes out and just straight down the drain, so that the water itself doesn't add any humidity to the house. And so far I've been letting this run for a little bit, and I plopped my Samsung temperature and motion sensor here right in front of it to get sort of an outlet temperature. And the room up here is already 78 degrees, and the temperature coming out of this is at 71 and dropping still. So and then all this is hooked up to this this plug, which, you know, it's not ideal right now for all these electronics plugged in there. So once this is like validated, I'm going to go on ahead and figure out some way to formally hook all this stuff up. But that's all hooked up to a GFI outlet and hooked up to a Z-Wave plug, or not a Z-Wave plug, a Zigbee plug. So basically, if the average temperature in the office drops below or above, or goes above the average temperature of the whole house, then these fans kick on and this fan kicks on and tries to bring the temperature of this room down. And this is put up here because this is the top room of the house. It's also got a shower that we never use anymore, and it's the one that's going to heat up the most during the day. So this room always needs a boost. If it didn't have this in there, and I'm hoping it works this way, but right now during the day, on a hot day, the office just gets so hot that it becomes the dominant temperature, the average temperature of the whole house. And so these booster fans are just permanently on. And then the living room never gets any boost, so it gets hot in the living room and then the whole house gets hot. So I'm hoping this will effectively boost the cold temperature in the office. If it's validated, I'm going to do some more work. I'm going to get a solenoid operated valve somewhere on here so that when the fan isn't running, like when that outlet cuts out, and it'll cut out the fan, it'll cut out the booster fan, it'll also cut off the water supply. So I can leave this on all day and not worry about wasting water. So, but for now, I've just got it running for today to see if it works. It happens to be a hot day. I want to see if the temperature drops in the house, and if it does, then success. I'll go on ahead and invest the time in figuring out how to cut off the water flow using my smart home stuff as well. But for now, just gonna let it run, see how cold I can get the office in the middle of the heat of the day. So hope you enjoy this video.